Okay, so our example was to take and graphically add a 45 Newton vector that was pointed due north to a 30 Newton vector due east and see what we get. So I'm just going to sketch this out over here real quick. I did this already, but this way I know I have it transferred to my graph paper. You don't need graph paper, any paper will work. 45 newtons north and 30 newtons east. Right, so the first thing I need to do is I need to set up a appropriate scale. Now the scale that I want to set up is something in centimeters that will be equal to so many newtons. So let's say we do let 1 centimeter equal 10 newtons. Okay, so I'm going to take my 45 newtons north. And if I use this scale, if I have 45 newtons, then I would need to represent the line, and it would be 4.5 centimeters long, and it would be pointed due north. So 4.5 due north. And when you do this, you're going to want to make sure that you're pretty exact with your arrowheads, not like I was right there. But I do know that the point of my line ended right here, because otherwise you're going to be adding on millimeters. And millimeters at the end of some of these can end up and add a lot of distance. Okay, so due north, 45 newtons. I'm going to label that due north. Now I'm going to add to that my 30 Newton vector. And remember, when we add vectors, we add tip to tail, and it's going east. So if I get my protractor, okay, mark out my 90 degrees. I'm going to go 3 centimeters.
Yeah, this is mine.
Okay, so if we measure 3, I've lined up my 90 degree mark. I'm going to measure over 3 centimeters to represent my 30 newtons. And then I'm going to draw my resultant. Now the resultant here is going to be the sum. Remember, we go tail to tail and tip to tip on the resultant. And this is my resultant. Now to figure out the distance, or the I guess it would be the sum of the forces here, because it's not a distance, we would take and we would simply measure this line. Now I'm going to go from the 10 because it's just a little bit more accurate. Go down here, and if you notice, I'm at about 5.5 centimeters. And using our scale of 1 centimeter equals 10 newtons, I'd take 5.5 times 10, and I would get 55 newtons. Now force is a vector quantity. We need magnitude and direction. We found the magnitude. Now we need to find the direction. So I'm going to use my protractor. I'm going to line it up, making sure I put it on the 0 mark, wherever 0 is. Line it up, and I'm at about 34 degrees. And that's this angle right here. In physics, we represent that with the Greek letter theta. So our angle is 34 degrees. And if we made our compass rose, right here, this is north, this is east, we've got south and west. I am east of the north line, so I'm 34 degrees east of north. Now you could have set your triangle up differently, and you could have set it up so that yours looked like this and then this. And then this angle wouldn't have been 34 degrees east of north, it would have been 56 degrees north of east. But it still would have had a magnitude of 55 newtons. So that's how you take and you graphically add vectors. You have to be very exact, very precise, accurate. Use a pencil, preferably not a pen. I just use a pen so it would show up a little bit better. Now you're going to do some practice problems. I'm going to pull those out of the book for you and I will post them on StudyWiz. If you do have a book, it's page 112 and 113, numbers 2, 3, 5, and 6. Hold on, Cohen. You'll do those to scale on your own paper with a ruler, with a protractor. I know you can do these things mathematically, but I don't want you to do that yet. I want you to do it using paper, pencil, protractor, ruler. Okay, so we can learn those skills.